Today I'd like to talk to you all about the human context, and this is going to be a big exploration of Google's Nearby APIs. We'll discuss what those are in the talk. First, a little bit of background on myself. So my name's Stuart Kent. I'm a mobile developer at Detroit Labs, and I've been there for about 2.25 years, which is exactly the same length of time that I've been developing, and also exactly the same length of time that I've been developing on mobile and Android. I've done some iOS stuff more recently. I have about 9 months worth of experience with that. And then I have about 2 months worth of experience with that logo on the right-hand side, which is the logo of the Nearby APIs. They are cross-platform, which is why experience on each of the other 2 platforms is relevant. So the tagline, the what I hope you understand by the end of the talk, is that the Nearby APIs, in Google's words, are designed for us to be able to build simple interactions between nearby devices and people. That's their stated goal for these APIs. And this is what kind of talk this is. I promised to give this talk knowing nothing about the subject, and figured it would be a good way to learn. So I haven't used this in production, but I've spent, like I say, about 2 months playing around with these APIs on both Android and iOS platforms, and I think I've got to that point where I did figure stuff out. The other caveat for this talk, any of you who are aware of what's going on in Google world right now will know that it's currently the last day of Google I/O, and really helpfully on Wednesday, Google announced a bunch of changes to the Nearby APIs. So I spent yesterday incorporating that into all of the samples. So this should be up to date with all of the latest changes that were mentioned on Wednesday. That was a little bit last minute though. So let's just go through a quick roadmap for what the talk's going to contain. I'd like to talk about some background and motivation, why we care about the Nearby APIs. And then just talk through the capabilities, what they offer us, what we can do with them, or at least without us, sort of building our applications on top, what their plain capabilities are. Then some practicalities. This will include things like code samples to show you what integration is like on the 2 platforms. A little bit on responsibilities. So this is the sort of best practices that you should make sure you adhere to if you're going to be using these APIs. And then lastly, just a brief discussion on what I see as the opportunities that are available in this space. These APIs have been around for a year now because they were announced around I/O last year. And apart from the initial release partners who had integrations built into their apps to sort of show off Nearby at its launch, I don't feel like this is something that's really been embraced very significantly, even though I think it has potential to be fairly impactful. And I think that the changes announced at I/O this year are going to push more people to start using it. So I'd like to talk about what kinds of things I think might be interesting spaces to explore using these APIs. So before we get into the specifics of the Nearby APIs, I'd just like to talk about what context-aware apps are, so we're all on the same page with that respect. So here's the shortest definition I could come up with that seemed to cover everything I wanted it to say. So a context-aware application is designed to observe, interpret, and then act based on the environment that it finds itself in. And conveniently for apps that are running on our phones, that is typically the same environment that we are in. So what constitutes your environment? We all have a bunch of apps on our phones already that use a bunch of these aspects of the environment to do smart things. So stuff like brightness. Your screen almost surely auto-adjusts for brightness. That's a reaction to the environment. Current time, your current location, your device's current orientation or acceleration, and maybe somewhat controversially, based on the definitions I read online, I'm going to think of you, the user, as being part of the environment of that application as well. Doesn't seem like such a huge leap to me. It seems fairly straightforward that from the point of view of the application, who's using it makes a difference, but I'm just going to call that out specifically because it's not necessarily common to see that association made. So when we have the environment, we need some observers to be able to turn whatever it is about the environment that we're interested in into something that's more easy to consume from your own applications. So typically this might be a hardware device. Hardware device is full of sensors that are taking measurements of the environment. And if it's something like user data, we can also rely on the user to provide us with streams of relevant information through, for example, your calendar. So you provide calendar events, and that becomes another stream of data that we can look at in order to figure out what's going on around you and what things are of interest to you. So once observers have done their work and sort of taken the raw environment and turned that into a stream of data, then we have actors that will take that raw data stream and use it to figure stuff out and eventually also proactively act based on that information. So some key examples here are Google Now obviously does a lot of aggregation of a lot of different kinds of data streams. Waze is pulling information about other users and their traffic conditions in order to inform you about what your route might want to be. And even your phone app can probably do something like be silent when you're at work or be silent during the night. That's looking at the time and figuring out how it should behave. So even the most basic function that we all started with on mobile devices, even when they were dumb, has now been made more smart by being more aware of what its context and your context is. So for a little bit of history, in 2001, this Futurama episode aired, and for those of you who are unaware, Futurama is set exactly 1,000 years into the future of when the air date for an episode was. So this was Futurama's 3001 world, and this is the quote from that show. My internet browser heard us saying the word fry, and it found a movie about Philip J. Fry for us. It also opened my calendar to Friday and ordered me some French fries. So in 2001, this was a joke that could be made, and it seemed, it was funny because it was as good as we could do right then. Like it seemed like, yes, even in the future we'll be able to hear things, but the capability to disambiguate between you saying fry and meaning one of 3 or 4 different things that include the phrase fry is a difficult challenge. One of the things that helps with this is having access to multiple different distinct streams. So for example, if the computer that had heard this had also known that Philip J. Fry was in the room, or that it had just been lunchtime and no one was likely to want French fries, it can make a more intelligent deduction about what the speaker was looking to find. And we've come a long way. These are some Google Now cards. These are some generic Google Now cards, not mine, but they give you a sense as to the number of different types of information we can pull and our interpreters and actors can use in order to make not just reactive but proactive decisions and to alert us to things that we might need to know. So we have come a long way in those 15 years. I'm not sure that the Futurama joke would be as funny anymore. So this talk in particular, I wanted to discuss the human context, and this is Aristotle, and this is his quote, that man is by nature a social animal. And I think that one of the things we've been missing still in 2016 is a good way to know who is around us from a device. Even if you think about sharing content, oftentimes the easiest way to share content from your phone to someone else's might be to send it via email across the internet and back again, not just to somehow get it from this device 3 inches away to another device. We do have options like NFC or Bluetooth, but they obviously have their limitations. NFC is a very, very, very short-range communications protocol, and Bluetooth typically requires pairing. So it's not been easy. It's not been easy to find out what's around you and, by extension, who is around you, which is a shame because that's kind of important to us, I would say. So this is where the Nearby APIs come in. And the idea is to augment what we know about our environment. We get a more refined picture of our environment. And the sensing is going to be done based on a device, typically your own mobile device. And what it means is that we get easier disambiguation of scenarios. And we also get, for example, easier transfer of information between nearby devices. But it also opens up this new category of apps where they can be explicitly based on knowing who's around you, not just what is around you. So I'd like to move on to talk about capabilities and exactly what you can do with these APIs. Again, just to recap, this is their goal, building simple interactions between nearby devices and people. And again, these are Google's words, and so Google emphasized the fact that this is about devices and about people. Even though it's not explicitly built in, it's very easy to use these to communicate information about people around you. We'll see some examples of that later. So currently there are two categories of the Nearby APIs. The third one was announced to I/O on Wednesday, so we won't be talking about that. The first is Nearby Connections, and as far as I can tell, I haven't looked into this one in too much depth, but it's a much more focused API where the objective is really to enhance multi-screen content for local multiplayer games, or to use devices as input devices for local games. That to me seems to have a fairly specific use case in mind, and so I haven't explored the capabilities of that too much. What's more interesting to me is the Nearby Messages API, and this is much more general purpose. It's a fairly simple interface, but you can build a lot on top of it. This diagram is ever so slightly misleading. It sort of implies there's a master publisher and then subscribers are just dumb recipients. We'll see in a bit that's not quite true. But for the rest of the talk, that's what we're gonna focus on. We'll focus on this general Nearby Messages API and what you can do with that, and why you might want to do things with that, and what kind of cool stuff hasn't been done yet. So to break down the capabilities, or a quick description of what these APIs are, they allow you to detect and communicate with nearby devices, and I should say they make it a lot easier to do this. So we've had things like Bluetooth around before. Using Bluetooth has never been the easiest thing. You often, especially on Android for example, have to worry about device capabilities. The Nearby Messages API is meant to be an abstraction around a lot of that, so you don't have to worry about how the actual communication is occurring. It's just a lot simpler, so you can worry about your own code. It gives us a simple publish and subscribe API, so publishers publish messages and subscribers listen for those same published messages. It's cross-platform, like all things recent Google. They've been pretty kind to us and given us cross-platform implementations of this with feature parity. So if you can do it on Android, you can do it on iOS and vice versa. That's kind of important for apps in this category. If you're gonna make a big deal about communicating with people, you probably don't want to segment your market based on whether they have this 50% or that 50%. So this is good to know, and good for pitching to clients. We don't have to worry about explaining to clients that only half their users will be able to use this feature. It's also unauthenticated, and I've put an asterisk here. There's no requirement that you authenticate. We'll come back to this a little later on. There are cases where you might want to authenticate, but you're not forced to. So you can publish anonymously. You don't have to do any kind of Google sign-in just to get this working. It's pretty simple to drop in and start using straight away. One of the really big features that sets us apart from using something like Bluetooth only is the fact that there are two ranges in which the Nearby APIs can operate. So the default range is about 100 feet, and this relies on using Bluetooth for that communication. But there's also an earshot mode, which is restricted to about 5 foot of range. So this is essentially giving you some pseudo-privacy by just being very local. My understanding is that 100 feet range will go through walls, and the 5 foot range will not pass through walls. So having this ability to tune your privacy or effective privacy by selecting the different modes is kind of interesting and kind of new. And we'll talk a little bit later about how that's actually achieved. It's very interesting. And then the Nearby APIs also include support for BLE beacons. I'm not going to get into that too much in this talk because I wanted to focus more on the people side of things than the beacon side of things, but I will say that the new announcement at I/O on Wednesday was sort of adding more beacon capabilities. So Google is very much thinking of beacon capability as a primary feature of this, as well as knowing more about the people around you. But again, it's a much easier wrap around beacon detection than doing it directly using Bluetooth. So there are, as I said in the previous slide, there are two main roles here. You can be a publisher and or a subscriber. If you're a publisher, you get to issue 0 or 1 messages at any given time. You can't issue a bunch of different messages. Either you are publishing or you are not publishing. You can, of course, well, I'll come back to that in a second because I can see what's on the next slide. If you're a subscriber, you can listen to all of the messages around you. So you're not restricted just to direct device-to-device communication. You will just say, I will accept anything that's being published around me. So the handheld can be both a publisher and a subscriber. This is your phone. And the dynamic in parentheses there indicates that you can change that single message over time. You can perhaps change it in response to what you are receiving from other devices. And then beacons can also publish. As far as I'm aware, there's no concept of a beacon subscribing. I'm not sure what it would do. But a beacon can issue static information, so you might use it to, for example, if I had a beacon in this room, I would be able to set it to broadcast that we are at self-conference, and then I could use the Nearby APIs to pull that information in and augment any of the other data streams that I'm getting with that. So the beacon provisioning is a few hoops to jump through because you need to provision with your beacon manufacturer and then also do some provisioning with Google itself, which is not trivial right now. Again, something that's going to be getting better as of the latest update to the Nearby APIs. So we're going to be focusing mostly on the handheld, which can be both a publisher and a subscriber, and I'm guessing for most use cases, that's probably what you'll want. You'll probably want your phone to be able to act as both. Whether or not that's simultaneous is up to you. And then sort of the other important thing in this API to know about is what a message is. What is this thing that you can send around? So typically, it just has to be something you can turn into a byte array. So something you can serialize to JSON or using a protocol buffer, which something you can turn into a string, let's say. Nothing too complicated. There are recommended sizes for performance reasons. It's recommended that the messages be less than 3 kilobytes on Android, and the best I could find for iOS was fairly small. So let's call that less than 3 kilobytes as well. That's not a terribly tough restriction, I wouldn't say. 3 kilobytes is a fair amount of data that you can cram in there. And the max, if you don't care about performance and you just want to test this thing and see how big an object you can transfer, is 100 kilobytes, and that's shared by both Android and iOS. And one of the takeaways from this should be that's probably too small to be sending images around, and 3 kilobytes, the recommended size, is definitely too small to be sending images around. So one of the sort of guidelines you should adhere to is sending references around rather than resources directly. So I might send a URL to an image to another device and have the other device fetch the image from that URL. You shouldn't be trying to pass around the images themselves. So let's talk about some practicalities, and I'd first like to talk about some of the communication methods that back these APIs. Now, I did just say that the APIs were designed to be simple and have you not need to know about how communication happens. But this is one of those cases where a lot of what we will talk about later is well informed by a little bit of a better understanding about how that communication happens. So, and it's interesting. It's that whole range situation that we have is achieved in a fairly novel way. So I'd like to go through sort of the discovery and messaging process, and then a lot of the other stuff that we'll talk about will make a lot more sense. So let's say I have a phone. I think this is our iPhone on the left-hand side. When I decide to publish, this is probably going to be way too small for you to read, correct? Okay, so I'll just make sure I say the things on those arrows as we go, and it shouldn't be too bad. So when I decide to publish, what will happen is I actually register a token with some Google Cloud somewhere. And I also have a published message that will go up to the cloud as well. When I want to broadcast this information, that token is what's going to be broadcast. The message is not broadcast directly. And this token can be broadcast in one of two ways, either by using Bluetooth or by using an ultrasonic modem in your phone. This is basically using your phone's speaker to make ultrasonic noises that you can't hear. Pretty cool. It turns out, the Nearby team have said this a couple times with mild surprise in their voices. It turns out that the hardware in our phones is good enough to do that. Obviously, you wouldn't necessarily think that the speaker in your phone would need to be able to make sounds that you can't hear, but it can. So why not use it? I have been told that some people will be able to hear this if you've got really good hearing, So that might be a little bit distracting. But yes, the key thing to say here is that it's the token that's being broadcast at this point by one of or both of those two methods. So when a subscriber comes along, and in this case it's our Android phone, and says, okay, I would like to subscribe, they will message that to the Google Cloud. And when they find a when they start to listen or scan, they will listen and scan using two technologies. Again, Bluetooth is one of those, and the other is the microphone in your phone. So again, the microphone in your phone is capable of picking up ultrasound, even though it was never intentionally designed for that. So this is pretty cool. So now let's say you find a token on the subscribing device. What will happen is the token is sent to the Google Cloud, and some validation will happen there to say, do I have a message waiting for this kind of token? And should I be passing this token to this subscriber? And assuming those things are both true, then the message will finally be delivered from the cloud to the second device. So we'll say a little bit more about that in a second, but this is a GIF of the output from the speaker of a phone that is broadcasting. So you can see, like right here, it's like 17 kilohertz, and that's 18 kilohertz is like the maximum range that we can hear. So it's just beyond the maximum range, and it sends out this kind of pulse, and then a pause, and then a pulse, and then a pause. That's not my mouse. They recorded, the people I sourced this from recorded this with their mouse in the video, which is unfortunate. But yeah, so you can see it sending like this pulse and then dropping away again. I just thought this was kind of cool to see. So yeah, let's just summarize all of this and say a bit about the implications. So it's the tokens that are communicated using the Bluetooth or the speaker and mic combination, not the messages. This is what gives us that range control. So when we want to broadcast it over a 100-foot range, we will be relying on Bluetooth primarily. When we want to restrict it way back down to that 5-foot range, Bluetooth is not involved at that point, and it's all about the ultrasonic modem. So that's how they've been able to achieve this really useful kind of human length scale of 5 feet for communications. The downside to this, as I'm sure you've guessed at this point, is that this means there's pretty heavy battery usage from using these APIs. If you're issuing Bluetooth tokens and you've got the speaker and the mic doing things all at the same time, you're going to be using battery. The number I've heard is that it's maybe 2 to 3 times your normal battery usage while this is active. So we'll see how that has sort of played into the design of the APIs in code as well. The message content is actually delivered via Google servers. It's never delivered directly from the device to the device. The pairing all happens with the token exchange, and the message content always ends up going via those Google servers. So you can consider this an extra layer of security or an extra layer of insecurity, depending on how you feel about Google and what they're doing with their servers. This also means, perhaps less obviously, that both devices have to be connected to the internet somehow for this to work, even though they're not using the internet as a broadcasting mechanism. And then for this to work, apps must also share a Google Developers Console project. For those of you who are not familiar, this means that you have to obtain API keys and sort of match them together in a single developer console project. And this acts like another layer of security. You will not be receiving messages from other apps. You will only be receiving messages from the app you have registered in the developers console. So that's not something you have to worry about. So some more practicalities. Let's talk about a demo and some code. So I told you at the beginning of this talk that I knew nothing when I said I would give the talk, and as part of learning about this, I built a little test app to teach me all of the things, especially all of the pain points involved in using these APIs. So I made this little app called Calling Card, and basically the idea is that you have a little card that represents your contact information, and you can publish that information, and other people around you can subscribe to it, and you can use it to trade contact information with people at, say, a conference. So a basic rundown of the other features. You authenticate with your Google account to do this, so this makes sure that the information that you're sending out is genuine. I don't want to be able to fake who I am and have people take Mickey Mouse contact information from me. It publishes your photo if available and name and email from that Google account. You can see nearby users by subscribing, and this app is built to use the 100-foot mode because it's a conference, so people aren't necessarily always standing next to each other. And then you can tap on a card to save it if you would like. So, like I said, I built apps from both sides. And I spent the last week, putting them on the store. So the source code is open for both. The Play Store link, if you want to follow it now, I'll leave this slide here for a minute. So I encourage you, if you want to download the app right now and start having a play with it while we're in this room together, because there should be people within 100 feet. This was my first time submitting an iOS app solo, and it didn't go so well. Mostly because I was very upfront about saying, this is a demo app, so I'm probably not going to add a whole bunch more features to it when they asked. And they said, well, you should probably use TestFlight. I didn't want to have to go through TestFlight and collect all your emails, so you will just have to build this from the repo. It's not too difficult if you want to play with this on iOS. Sorry. One thing that's kind of cool that I learned during the development of this is that if you're running an app that uses Nearby on your Mac, it will use your Mac Bluetooth to do all the connection stuff. So you can actually test it with a real Android device and the iOS simulator running on a Mac, and that works fine. So that's. I can't promise, no, because my testing was typically within 5 feet, so well, it works somehow. I didn't investigate exactly how. I guess I could have listened for the ultrasound with an app and seen if I could detect that ultrasound signature. But yeah, basically it's a lot less of a pain than I thought it was going to be to develop on the iOS simulator. Okay, so if you want to implement apps, these are the main, these APIs in your apps, these are the main things you end up dealing with. There's a runtime permission required for accessing these APIs on both platforms. That's something that's a little bit new on Android, and the implementation is a little bit interesting. I'll talk about that when we get there. You need to handle serializing and deserializing your messages on both platforms. And maybe not so obviously, but something that caught me out a few times over is the message serialization, deserialization needs to adhere to a single spec between iOS and Android. Because if you want Android messages to play nice on iOS devices, it has to be in the right format. So make sure your fields and field naming and everything is identical between the two. On Android only, remember how we were saying this is super battery heavy? It's so battery heavy that whenever any app is using Nearby, the Android system will show a notification allowing you to immediately immediately stop any app that is currently using Nearby from using it. So you get some callbacks for that in the Android API, and you should be good about tearing down your implementation if you receive one of those callbacks. That's not something you have to worry about with iOS. And then finally, just making sure that you do all the appropriate teardown when your activity or your UI view controller is moving off screen, just to make sure you don't leave any very expensive battery operations running. So I'm going to go through some snippets of the source code. These will all have been pulled from the repos that I showed briefly earlier. Slides will all be available online, so don't feel the need to try and follow along too closely. I'll try and give more of a gist than like step by step. These are all the things you must do or else. So in your dependencies in your Gradle file, you should pull in the Play Services Nearby dependency. And look, it's version 9.0.0 released 2 days ago. In your Android manifest, you need to declare some metadata. In particular, you need to give the API key that you created in the Google developer or the Google API console for this application. Then when you want to publish a message, there's a bunch of different things you have to prepare to do so. So the access is just nearby.messages.publish and then a bunch of things that we'll talk about. So the first is a Google API client. Anyone who's developed an Android is familiar with this. In particular, when we create this client, we want to add the Nearby Messages API to our client. This will allow us to access all of the nearby messages stuff that we want to. And one of the changes that was made recently, Wednesday, was that when you try and connect this client, that's when the user is going to be prompted for permission to use the nearby APIs. So before it was a little bit later in the process when you actually made the publish call. Now it's going to be as soon as you connect that Google API client. That's when they're going to prompt for permission. It sounds like it might be a bit aggressive, but it's actually a lot nicer to handle, mainly because previously you had to do the same kind of callback handling for publishing and subscribing. Now it's all centralized. As soon as you connect that client, you're going to know once you get to a successful publish or subscribe that you have all the capabilities and all the permissions that you need. The first time you try to connect, what's going to happen is an expected failure. So it will fail with an error code that indicates that the permission is not granted yet. And the way that you deal with that, again, a very standard Android pattern is you say, okay, I got this connection result that said I did not have permissions yet. It will have a resolution available, so you can use start resolution for result, and that will be what triggers showing the prompt to the user to say, can I have this permission? It looks like this. It's not very scary. Earlier versions of this had a lot more detail. This may also be the sort of two stages of allowing Nearby to work. They're sort of at the system level and then on the individual app level. So this screenshot may just be showing the individual app. I forget. So assuming they allow, you'll get an on-activity result from this permissions dialog. And you should, as a good citizen, check that you are getting the result back from the activity that you started, so using this nearby code that you define. And then if all has gone well and the request was that I wanted the nearby permission and the result was yes, you can have it, then go ahead and try and reconnect that client. And this time it should go smoothly because there's no issue with you not having that permission anymore. The second component to publishing is the actual message that you're going to send out. This is not too tricky. The only thing, as I said before, is to make sure that you serialize this and turn it into a byte stream. So in this particular case, I'm on Android, so I'm going to use JSON or Jackson or something. I just turn my user object in this case into a string and then call getBytes on that string. One thing to note here is that I'm retaining a reference to the message itself. That will be something that comes back up again in a second. And then there's a big warning sign in the corner of the slide. That's because I'm pretty sure Google broke this in that update on Wednesday. So this is how it's supposed to work. They told me they were going to look into it internally yesterday, but I didn't hear back. So I will tell you what's supposed to happen. It doesn't happen right now. Hopefully it will be fixed in the next version of Play Services. So the last option here is publish options. In the example app, I don't use this for much, but you can use this. This is where you would control things like the role you're playing. You can either be publishing or subscribing or publishing and subscribing. And this is also where you do any setting of range limitations if you want this to be earshot mode of 5 feet or the 100 feet. In this case, all I'm doing is setting a callback, which is this publish callback type. And what that does is listen for that nearby notification stop button press. So if someone presses stop on that nearby notification, this on-expired callback will get triggered. And what you should do there is just cancel all of the operations you were previously doing with Nearby. They basically said, no, please stop using this. Right now, it doesn't work. You press stop, and that on-expired never gets triggered. It was working in the previous version of Play Services, so not entirely sure what to do there. Just a little bit broken for now, I think. When you want to unpublish, you provide the same Google API client, and that message from before, which is why it's important to retain a reference to it, that also needs to be part of it. So that's the exact same message that you stored earlier. And when you're subscribing, fairly similar. There's a bunch of different things to set up. The Google API client is the same instance that you had hanging around before. So you need to do all the same work there if you've not already connected this and obtained the permission. You then just provide a listener, and this listener has two callbacks. You'll be told when a message has been found for the first time, and you'll be told when a message has been lost for the first time. And it's up to you to maintain some state which allows you to store, this is the list of currently visible messages. So typically in onFound, you would add your message to some list, and on onLost, you would remove it from that list. And then subscription options follow the same API as publish options. So again, you can set role, you can set range, and you can set this callback that doesn't ever get called for the unexpired. When you want to unsubscribe, again, very similar pattern. You provide the Google API client, and also you have to retain that listener that you were using to receive the message found and message lost callbacks. That's provided into the unsubscribe call also. So kind of the last phase is just to make sure that you are being a good citizen. When your activity stops, you should at this point cancel all your nearby operations and also disconnect your Google API client just to make sure nothing's hanging around and using battery when you didn't think it was. So now let's talk a little bit about the iOS implementation. This is easier than the Android implementation because you don't have so much juggling with the Google API client to do. It's a handy pod, so this is the Podfile, or a snippet of the Podfile. I will just note I haven't upgraded to CocoaPods 1.0 yet, so this is from 0.39 still. But you just include the pod with a specified or unspecified dependency version. If you're writing your app in Swift, you should be writing your app in Swift. The library is written in Objective-C, so you'll need a bridging header where you import this GNS messages.h indicator. And then this is the equivalent of messing around with the Google API client. You just create this message manager object somewhere in your view controller or in your app delegate, and you'll need to provide it the API key when you initialize. When you want to build your message, you'll want to do something like take your user model, and in my case I found the easiest thing to do was to write an extension on the model that would turn it into NS data for me. Assuming that succeeds, go ahead and return that, and if it doesn't, then, well, you're not going to have anything to send in the appropriate manner anyway. So that's, yeah, the user data is what's sent as the serialized content inside the message. Before you actually try and connect, there's this permission proxy that is wise to set up. This is kind of what's going to get the callback when you are granted or denied permission to use the Nearby APIs. So this is a little bit more direct than the whole Google API clients. Wait till I fail, then try and resolve it, then assume it was resolved. This is more of a, try your thing and you'll get a callback to tell you if the permission state changed, and you can respond to that appropriately when you know how the permission state changed. So if it was granted, go ahead and do all your active UI stuff. And if it was not granted, do all your teardown and cancel anything that you were in the middle of trying. So the way that subscription or publication and unpublication works is a little bit different in iOS. You take this message manager that you just configured and you call publication with message and provide a message. This is what will trigger showing the permissions dialog if you haven't already granted permission. And I haven't used any extra parameters here for controlling the role and the range. Remember the publish options for Android, the only thing I used there was this callback for the notification kill, and that doesn't exist on iOS, so no need for that here. But I am retaining a reference to this current pub, which is a publication returned by this call. So the way to cancel this publication is actually just to release that reference. So whenever you're holding on to that reference, it's going to be publishing, and whenever that reference is nil, or nilling out that reference will cancel the publication. Similar kind of thing for subscription. The only extra here is that you, when you call the subscription method, again, you provide that found message, lost message type interface. So you can say, when I first find a message, deserialize it and store it somewhere. And when I lose a message, take that back out of my store. The subscription unsubscription mechanism is the same, where I need to hold on to a reference to the subscription, and then if I want to stop subscribing, I just release that reference, and everything's all gone. So again, for being a good citizen, when your view is about to disappear or on some other appropriate lifecycle callback, tear down all of your nearby operations stuff. Don't leave anything running inadvertently in the background. So what are some responsibilities that you owe to your users when you are using these APIs? I've talked about this one a lot, but it probably can't be restated enough. Be a good citizen of the ecosystem and make sure you are doing all the things that respect battery drain and battery usage. Google has made it pretty hard to ignore this, so it's not too much of a problem. I haven't said anything about beacons so far, but beacon stuff can be run in the background. You can scan for BLE beacons in the background. You should not be scanning for other publish subscribe messages in the background. It's very clearly stated that this is a foreground activity only. And obviously that informs your app design to a significant extent. Another thing to be aware of is privacy. So this headline is a little bit misleading for the article content, but it's a classic kind of media spin on the stuff that we have to deal with. So this is suggesting that Pocket Casts has added this feature that lets you spy on people nearby. Google's very clear, and the API that we're given makes it extremely difficult for you to secretly spy on people. There's a very distinct, you must press a button or take an action to make publishing or subscribing happen. This is a lot scarier sounding. On the flip side, you do want to consider, based on your use case, whether you would prefer your users to remain anonymous or whether you want to guarantee that they are who they say they are. So I mentioned this a little earlier with Calling Card, the demo app. In that case, where you're sharing contact information with someone, it's very likely that you would greatly prefer authenticity versus anonymity in that case. So think carefully about whether you are, which camp your application falls into. Along these same lines, I'm not sure if any of you are familiar with Yik Yak. This caught some flack probably a year or so ago now. It's a location-based social network on a much larger scale of location, I think typically geofenced, where you can chat anonymously with other people in your general area. And bad things happened as a result of this. A bunch of news stories. Like all other anonymous platforms, there are problems. So keep that kind of thing in mind when you are making your choice about anonymity versus authenticity. And again, just to come back, so Calling Card, I didn't show this earlier, I don't think, but it's completely locked by a Google sign-in, so you must authenticate before you can use the rest of the features of the application. Again, there's no requirement here. It's all just a choice based on what it is that you're trying to achieve. So let's talk about some opportunities. There are 4 main trajectories I'd like to mention briefly. Augmentation is the first, foundation is the second, competition is the third, and evolution is the fourth. And none of these are going to be super in-depth, just some inspiration maybe for when you leave the talk. So augmentation has been kind of what we've seen a lot so far. So when the Nearby APIs were launched, there were a few partner applications that brought out implementations almost immediately. Pocket Casts is one of them. For those of you not familiar, it's a podcast app on Android. I think actually it's on a bunch of platforms now. It's my preferred podcasting app. And they added a feature where you can, when you're in your discovery page, that's sort of the, where you can find podcasts that you might be interested in, they added a tab for Nearby specifically. And I haven't shown it here, but there's a bunch of, you have to explicitly say, okay, look for podcasts near me. And what you'll get if you find people near you who are also using the app and also issuing from this Nearby tab is an indication of which podcasts they have that you do not have subscribed. So it's not groundbreaking for the app itself. It's just another discovery mechanism. So that's what I mean when I say this is kind of an augmentation. It takes the existing functionality and adds a slightly more convenient way to maybe share podcasts with your friend. That's kind of what we've seen a lot of so far. More recently, in the last month or two, we've started to see apps that are exploring these Nearby APIs as kind of the foundation of their entire model. So Calling Card, as an example, would fall into this. The whole point of the app is to be leveraging these APIs in order to share contact information. So Radon on the left here is a link sharing app that allows you to just more easily share links with people. And then Cardcase is actually more of a developed version of Calling Card that I discovered like a couple of days ago. It basically does all the same things, but better, because it's not a demo app. But it's exactly the same kind of idea. You can issue contact information and other people can save that contact information. So far, the criticism I've seen of that app is that it's not integrated yet with your actual phone contacts, but that is a very logical next step. And this is where I think maybe the biggest opportunity is right now. for some new and interesting app ideas to come from. I don't think there's been a lot of exploration in this space, but I think there's probably a lot more opportunities out there that people have not jumped on yet. So this could be you. I want you to go and see what you can think of with using the Nearby APIs as the foundation of your app. Competition. I wanted to give a shout out to these guys. A bunch of the images and the GIF that I showed earlier were actually created by this P2P kit company. They wrote a blog post comparing Nearby to their own services when Nearby was first released. And they work in a very similar field where they're all about proximity of devices. I think they've been around longer, and I haven't explored their API, but the claims sound like it's a much more mature version of Nearby. So this is a classic case of, the field has been legitimized now by Google entering as a major player. That doesn't necessarily mean they're the only player. So if you're looking for ideas and looking to do something with Nearby that's not available yet, there are other things out there that may be mature and useful to you. So don't necessarily get trapped into Nearby as the only option. There are others out there. And then evolution. So as I say, Google announced on Wednesday a third category of Nearby API, and this was Nearby notifications. So what this is, I don't know if you can read the right-hand side there. I can just about read it. It says, it's an opt-in dialogue that I stole from one of their slides that says, Nearby shows you apps or website from things around you, including your new devices. So some of the use cases for this are, this is mostly based on beacons, and some of the use cases might be, there's a beacon in a store, and when you walk into the store, it will say, hey, we have an app, you should install it. Or it might just be like a welcome message. Or it might be a specific product you go up to, and then you are linked straight to the product page in that app from your phone from a notification. So Google is thinking about where this can go. Again, I didn't cover the notifications or the Bluetooth beacon side of this very much in this talk, but there's some cool stuff coming, and I think that it's going to be an interesting. I think it's going to be interesting in a much more prominent space over the next few years. So I'd encourage you to keep an eye out on what's going on with Nearby. And that's what I had. So just to recap, that's me. You can email me there or find me on Twitter at skentphd. Thanks, and thanks to the organizers for having me. Any questions? Yeah.
I don't know if you know, but do you know if when it uses sound to determine like within 5 feet, is that affected at all by either ambient noise or sound dampening?
That's a great question, and so I managed yesterday to watch the session from Wednesday where they talked about Nearby, and they did have a brief description there of how they generate that sound, and I'm not a signal processing guy, but the gist of it was that they take a signal which is determined by the unique in time token that they've generated, and mix in some noise, mix in some like static to begin with. And that makes it much more robust against other noise in the environment. I guess the other benefit is that because it's only supposed to work on a 5-foot range, you're probably going to be closer to the other device than to most other noise sources. In my own testing, I haven't really experienced separate noise being a significant issue in terms of that pairing.
Thank you.
Sure. Yeah.
The sounds, I don't know what animals can hear, but do you know if that's in a range that animals can hear at all?
Pretty sure it is.
Really?
Yeah.
That's interesting.
Yeah. I don't know exactly. I have a Nexus 6, and I can hear it like crackle when the microphone when the speaker starts to issue. So it's pretty close. Like I say, 17, 18 is kind of the top of our range, and it's right there at 18 to 20. So.
You say the younger you are, like teenagers are more likely to hear it.
Yes, yeah. So I guess listen to your teenagers if you have them. If they start complaining about weird noises in the house, then you might have an issue. Okay, I think I'm a few minutes over, so I better wrap up. But thank you again.